In this video, we're going to continue our review of Unit 1. This will be Part 2. And we're going to be starting with number 9. This question is asking you to write two equivalent fractions, and they're asking you to use a split fraction bar to justify your answer. I'm going to show you how to do the split fraction bar, but I'm not going to make it mandatory that you use one in order to answer this question. You can use any skills that you have, any method that you want to find equivalent fractions. So I've went ahead and changed the question to 6/10, and most likely you're going to be using a different method than split fraction bars. So just to remind you of some of the tools that we have, if we're taking 6/10 and want to create equal fractions to 6/10, we can do this always by multiplying the top and bottom number, our numerator and denominator, by the same number. That will always work. So we could just start off by using 2 as a multiplier and getting 12/20. This would be equal to 6/10. And we could do that again by using 3. 6 times 3, which is 18. 10 times 3, which is 30. We also could have multiplied 12 times 3 and 20 times 3, and we would get equivalent fractions that way as well. So there are two equivalent fractions right here. Of course, we could have done the opposite because we have a fraction here that's not simplified. So one of our equivalent fractions we could have gotten by simplifying, dividing both the numerator and denominator here by 2. We would have gotten 3/5. That also would work for an equal fraction. Here I have a fraction bar, and it's representing 6/10. You can see that here. There's 1, 2, 3, 4, 5, 6 that you have shaded out of 7, 8, 9, 10. So if you started with the fraction representing that with a fraction bar, 6/10, you could then use this fraction bar to split it. We talked about using an in split, a 2 split, or a 3 split. So if you split this all in half one more time, each section gets split into 2. You now have a different fraction, but the amount shaded is still equal to the original amount. So what you need to do is count how many shaded parts you have now, which is now 2 for every one we had before, or 2, 4, 6, 8, 10, 12, out of a total of 14, 16, 18, 20. If you put these next to each other, you'll see why this works. When looking at these two fractions, how can you prove that they're equal? The way to prove that they're equal, as we've done in an earlier problem, is to find a multiple for either the numerators or the denominators and make sure that it works for the opposite side. So the multiplier here would be times 2, which is 12, and it works for the bottom, 10 times 2, which is 20. So we know those two are equal. That would find one equal fraction. You would have to then split it again if you wanted to use this method. And you could go through and split each section again one more time. And in essence, what we're doing here is doubling the number of equal places that we have. We're doubling it again. Or we're using a multiplier of 2. So now, if you count your equal places, and they're getting difficult to count, you would end up with 40 equal places, and out of that you would have 24 shaded. So 24/40 is also equal to 6/10. And here we have our 6/10 original and our two equal fractions. Number 10 is asking you to change improper fractions to proper mixed numbers. And we come across improper fractions all the time when we're adding fractions, and we'll be coming across them just as many times when we're multiplying them. So it's really a simple formula that you just need to memorize. If you have an improper fraction like 21/8, really you need to see this as a division problem. You can write this out as a division problem and solve it. 8 goes into 21 2 times, that's 16. Subtract, you get 5 left over. The 5 is what you have. What it takes to make a whole is still 8. So 21/8 can be converted into 2 and 5/8. I also look at that a lot as like a pizza problem. It takes 8 pieces to make a whole pizza. I have 21 pieces. You could draw pictures. It takes 8 pieces to make a whole pizza. You could draw pictures of pizzas cut into 8 pieces. And then you could fill in the pieces that you have. You have 21 pieces, so there would be 8 pieces here, another 8 here, which is 16, and there would be 5 pieces left over to fill this box. So you can visually see that you have one hole here, one hole here, that's 2 holes, plus 5/8 of a hole. Really, you need to just get into the habit of dividing. That's going to be the quickest way to do this. On number 11, there are 5 questions there actually. You're just checking yes or no as to whether or not the fractions are equal. A quick demonstration of that. All you really need to do here, we've done this a couple of times already, is to look for a multiple, find a rule. How do you go from 2 to 8? And that rule would be times 4, and make sure that that also applies to the denominators, and if it does, then they are equal. 4 times 4 is 16, so these two would be equal. That would be a big yes. And on the second example, we're looking for a rule. How do you go from 3 to 5? There is no rule. How do you go from 4 to 6? There is no rule, so this would be a no. If you can't find a rule to go from one numerator to the next or one denominator to the next, then they cannot be equal. In this last example, realize that sometimes the rule may not be multiplication, it could be still division. In this problem, the rule is going to be divide by 3, and that also works for the denominator, so these two are equal as well. When you're looking at these particular problems, it's okay to go backwards when looking for the rule if that's simpler. Finding a division rule, a divisor, is probably more difficult than it is to find a multiple. So if you're going from large to small, you know you're going to have to divide. But if you reverse that and go from small to large, you could use the rule times 3. And you know that equals 15, and then 6 times 3 equals 18. That might be faster for you. Here on number 12, there are really 4 problems. There are addition and subtraction, so the first thing you want to do is make sure you locate the sign and do the right thing. I have an example problem over here. So the first thing we want to do is rewrite it standing up, which is done already for you. The second thing would be to find the common denominator. We could find that here by multiplying 5 times 4. And then we want to locate our multipliers for each one so we can get our new numerators. Our multiplier here is times 4. Times 4 on the top will get you 12. Our multiplier here is times 5. Times 5 on the top will get you 5. We're going to add these two together, 12 and 5, to get 17 over 20. The final step, of course, is to check your fraction and see if it's improper. It is not improper here. And also check to see if you can simplify. 17 is a prime number. There's only 1 and 17 that goes into that. So 17 would have to go into 20 in order to simplify, and it cannot. So we are finished with that problem. For this problem, I'm just going to tell you what it is you need to be doing. I couldn't fit the entire question on here, but it's a word problem. You're going to use the tips and tricks that I taught you for word problems. You're going to figure out whether you're adding or subtracting these fractions, and you're going to input them in the boxes that they give you. You're only going to be using the numbers that you see in front of you, so all of these numbers here and these numbers and these two signs are the only things you're going to need. That makes total sense. You're either going to be adding or subtracting. That will go in this box. You need to put your fractions that are up here in these boxes here. And these boxes are here for what reason? Well, it's because your denominators here are different. You have an 8 and a 4 as your denominators. You're going to need to change those into equal denominators. And the entire question is not shown here, but underneath that, you will have some boxes for you to put your answer. So don't let these numbers here throw you off your game. It's not making it any more difficult. In fact, you don't probably even need them. They're supposed to be a help to you, but I'm sure you could solve this problem on your own without the use of them. However, they could help you check your answer, because if your answer has any numbers that you don't see up here, then you probably want to go back and recheck your work. Number 14. I am riding my bike 3 1/4 miles to the park. I ride 1 1/8 mile and stop to take a drink. How much further do I have to ride to get to the park? On a question like this, I like to draw or doodle some sketch drawings here. So I'm going to just draw a line. The beginning of that line is going to be my home. And the end of that line is going to be my final destination, the park. And I know from my home to the park is 3 1/4 mile because it tells me that. It's 3 1/4 miles to the park. And I know I stopped somewhere to take a drink. I stopped after I rode 1 1/8 mile. So where I put this next line doesn't matter much, but it should kind of represent 1 1/8 mile. 1 1/8 mile isn't quite half of the distance, so I'm putting that line to represent not quite half, and that is 1 1/8 of a mile. So I can see now that I need to ride 3 1/4, but I've already ridden some of the distance, so I can subtract the distance that I've already ran from in order to find the distance that I still need to go. So I'm going to take my 3 1/4 and subtract that, or subtract from that 1 1/8. I'm going to find a common denominator. 8 would be my best. Numerator will stay the same. My multiple on top is 2, so that will become a 2. 2 minus 1 is 1, 1/8, and 3 minus 1 is 2. So I still have 2 1/8 miles left. You could always check that answer because you said here that from your home to the park is 3 1/4 miles, so we could add our two fractions that we have here, 1 1/8 with 2 1/8, and we should get 3 1/4. And the answer makes perfect reasonable sense. I know my answer should be less than 3 1/4 because I've already ridden some of the distance, so my answer matches that with 2 1/8. For our last problem, I'm going to change I'm going to actually change the stem of the question. I'm not going to ask you to estimate here. I'm just going to ask you to tell me exactly how much punch was served at the party. There's no need to explain your estimation. And that will not be a requirement on the actual test either. So you're going to practice it here the way you will take the test. And so when you do your homework, make sure you cross out the estimate part and the explain how you estimated part. And here we have a situation where I'm mixing 2 1/3 pints of grape juice and 3 1/8 pints of cranberry juice to make punch for a party. And at the end of the party, I still have 4 pints of punch left. So the question is, how much punch got served at the party? So in order to find the answer to that question, I need to first find out how much punch I started with. And sometimes it's a little easier to make up a new problem and maybe estimate these numbers instead of using the fractions, just to see if we're on the right track and we're choosing the right operation. So let's just knock the fractions off of here and say instead that I mixed 2 pints of grape juice plus 3 pints of cranberry juice. And how much total punch would I have? I would have 5. And if that's true, and at the end of the night when I go to collect the punch, I still have 4 pints left, then I need to figure out which operation I'm going to use to find out how much punch my guests had been drinking. And I might start with subtraction, which would leave me with 1 pint, and I would check my answer to see if that is reasonable. And it seems reasonable because I have a lot left. I started with 5, but I still have 4 left, so it seems quite reasonable that my guests had been drinking only 1 pint. If I were to choose a different operation like addition, I would end up with 9 pints, and that wouldn't make any sense at all because I only started with 5, so it would be impossible, or less likely obviously, to end up with more punch than what I started with. So sometimes I think by estimating, you can make a problem simpler and can solve it fast because the numbers are easier to work with, and you can estimate and figure out what option or operation you want to use that way, and then go repeat the process. Now that I know I'm going to be first adding my 2 fractions to see how much punch I mixed, and how much we started with, I will be adding the entire mixed numbers. I find my common denominator, 24. My numerator here is 8, and my numerator here is 3. And add those together and see that I started with 5 and 11/24 pints of punch. And from this number, 5 and 11/24, I need to subtract 4, which leaves me with 1 and 11/24. And remember, there's nothing here, there's no fraction next to the 4, which is essentially the same as 0 over 0. If you want to keep the denominators the same, you can. It's the same as 0 over 24. If you have 0 out of 24, you have 0. And so 11 minus 0 is still 11.